Hello everyone, this is a video presentation for AMA1501 Introduction to Statistics for Business. We are from Wednesday class 12:30 until 1:30. There are 5 members in our group: Leonie, Jingqi, Sanidi, Yucha, and Muhammad Ali. In this video, we will answer 3 questions.
Hello everyone, we are group 3. Today we'll present some of the questions. Now let's start with 2015-2016 semester 1, question 3A first. So it's given that the customer's waiting time for collecting food and drinks at a cafe kiosk follows the normal distribution approximately, with a mean of 4 minutes and a standard deviation of 1.2 minutes. So it's asked us to calculate the probability of a randomly selected customer who waits for more than 3 minutes for collecting food and drinks. So, in the description it's explicitly given that it's normal distribution and has a mean of 4 minutes and a standard deviation of 1.2 minutes. So we can write it like this. Its normal distribution is denoted as x and mean and variance, and it's given that the mean is 4 minutes and the variance is 1.2 square minutes. Because 1.2 is standard deviation, its square is our variance. So now it's asked us to calculate the probability of a randomly selected customer who waits for more than 3 minutes for collecting food and drinks. In order to calculate this question, first we need to determine the x. So now we can say that let x be the customer's waiting time for collecting food and drinks. And we can write our normal distribution as x and 4, which is our mean, and 1.2 square, which is our variance. And we need to calculate the probability of customer who wait more than 3 minutes, which is denoted as px is greater than 3. So because the mean is 4 and we need to make it transform it into standard form, standard normal distribution, so its formula is as z equal to x minus mean divided by standard deviation, which is also like this. So if we apply this formula to our question, we get probability x minus mean divided by standard deviation greater than 3 minus mean divided by standard deviation. And if we write the numbers for the mean and standard deviation, we get probability like this, and this part is z and this part is minus 0.833 after our calculations. So now we need to draw a graph for better understanding. If we draw a graph, we see that minus 0.833 is here, and x, if x is greater than it, the area we need is the shaded area, so the area greater than this. Because the graph is symmetrical, if we look at the right hand side, we see that this area greater than 0.833 is equal to area smaller than minus 0.833. So, and we know that the area under this graph is 1, and if we minus this area from 1, we can get the probability that we need. So in order to calculate this area, we need to go to table of standardized normal distribution. So our z is 0.833, we find 0.8 and then 0.83. So we find that that area is 0.2033. So we write 0.2033 and the total is 1, and 1 minus 0.2033 is equal to 0.7967. So our answer is 0.7967.
Moving on to the second part of question 3a, the question is what is the waiting time within which 95% of customers collect their food and drinks? And so, let A be the waiting time within which 95% of customers collect their food and drinks, and let X be the customer's waiting time for collecting food and drinks. And we got this is the mean 4 and the standard deviation 1.2. The probability of X less than or equal to A is 95%, and this is equivalent to this. The probability of X more than or equal to A is 5%. And then we apply the formula, we got the A minus the mean 4 divided by the standard deviation 1.2 is 5%. And then look at this, we have to find the z value of 5%, and to find that we have to look at the table of the standardized normal distribution. So from this table, first of all, we have to find the 5%, and we can see that the 5% is between this and this, and then so the z value of 5% is 1.645. And then from the table, we found out that the z value of 5% is 1.645. We times it with 1.2, we got 1.974. And then we add it with 4, we got 5.974. And so the waiting time within which 95% of customers collect their food and drinks is 5.974 minutes.
So now let's move on to Semester 2 question 3a. The daily sales amount of a snack shop in a certain district follows a normal distribution with a mean of 5,000 and a standard deviation of 400. So the question asks us to calculate the probability that a randomly selected day has sales amount between 3,860 and 5,460. So for the solution, we let X be the sales amount of the snack shop, and this is the mean of 5,000 and standard deviation of 400. So for the notation, the mean of 5,000 and the standard deviation of 400. And for the sales amount X, it should be larger than 3,860 but smaller than 5,460. And through the theorem over here, we can get 3,860 minus the mean of 5,000 divided by the standard deviation of 400. And over here, 5,460 minus the mean of 5,000 divided by the standard deviation of 400. And through simple calculation, you can get Z should be larger than negative 2.85 but smaller than 1.15, which is shown in the graph over here. We should find the probability of the shaded region. So we take 1 minus Z smaller than negative 2.85 minus Z larger than 1.15, which is similar to 1 minus Z larger than positive 2.85 minus Z larger than 1.15. And through the standardized normal distribution table over here, we can find that the probability of 2.85 is 0.00219, and the probability of 1.15 is 0.1251. So we take 1 minus 0.00219 minus 0.1251, which will get the answer, the probability of 0.87271.
Hi, my name is Yuja, so I'm going to solve the second question. Find the amount that there is a probability of 0.025 with daily sales amount below it. So first, let's set A be the amount that there is a probability of 0.025 with daily sales amount below it. And the mean is 5,000 and the standard deviation is 400, so we'll get this step. And the third step, as told by the question, the probabilities is 0.025. We make X into the standardized distribution format and refer to the standardized normal distribution form, which is 0.025 is here, so we get 1.96. And as the distribution is at the negative side, so it will be negative 1.96. And we do the job, and lastly we will get the answer, which is 4,216.
Lastly, I'm going to do question 3 from our paper 3. The daily sales amount of a cake shop is normally distributed with the mean 10,000 and standard deviation of 2,500. What is the probability that the sales amount of the cake shop is between 7,500 and 14,000? Firstly, the question is expressed in this format with the mean 10,000 and the standard deviation 2,500. And since they are asking the probability that the sales amount of the cake shop is between 7,500 and 14,000, you write the x values in this format. Next, to find the critical value, you deduct 10,000 from 7,500 and divide it by the standard deviation, which is 2,500. Next, to find the critical value of this, you deduct 10,000, which is the mean, and divide it by 2,500. And the critical values for 7,500 and 14,000 is -1 and 1.6. When you express it in the diagram, probability is between -1 and 1.6. So you find the probability of this following area. To find the probability of this area, you should minus it the whole probability from 1. So probability of the critical value -1 and the probability of the critical value of 1.6 should be deducted from 1. So to find the probability of the critical value of -1, you check it from the table 0 and 1, which is 0.1587, which is this. And to find the critical value of 1.6, you check it from the table 0 and 1.6, which is 0.048, and then you minus it 0.048. You minus these two probabilities from 1 because we are finding the area of this part, and then you get the answer 0.7865.
Next, I'm gonna do part 2 of question 3a. Determine the daily sales amount such that 90% of the days are having sales amounts more than 8.
We take A as the value of daily sales amount, so we write this as x greater than A is equals to 0.9. And since the probability of 0.9 is not given in the table, we write this x less than A is equals to 0.1. And then we subtract the mean, which is 10,000, from A and divide it by the standard deviation, which is 2,500, and equal it to the probability, which is 0.1. And to find the critical value, which gives the probability of 0.1, we look it from the table. Over here, this is the closest value to 0.1, which is 1.28, and then we equal this to 1.28. However, we have to draw the diagram and check whether this critical value is minus or plus. Since it's less than and the value is less than 0.5, you mark 0.1 over here in this area, which is negative. So we equal A minus 10,000 over 2,500 to minus 1.28, and then we find the value of A, which is 6,800.